All right, students, are you ready for this one? This is the last exercise in OS3, number 9, the legendary Narwhalone. I'm not entirely sure that this is the official IUPAC name, but if I were going to give this molecule a name, that's certainly what I'd call it. This one is challenging, so before you get started, make sure your pencils are sharp, make sure you have a well-stocked supply of Coca-Cola Cherry Zero, because you're going to need all of your neurons firing for this one. This one is one that I would expect that you would be able to make good progress on, particularly with some persistence, particularly if you're using your free gift, if you're working together with some of your classmates and peers. This is more challenging than any that I would put on the test. But I think if you given some time and some help, you should be able to make at least some progress on it. Let's look at this one. So in blue here is the original reaction, right? And you notice right off the bat, we've altered the carbon skeleton, and we've altered it in a couple of different substantial ways. Also, there are a whole bunch of functional groups in the reactants that are not present in the product. I'm going to start with that pesky carbon skeleton because one of the things I notice is it's very different, right? Here's 5 carbons sort of all in a row connected, then an ester group, then a 6th carbon over here. In the product, I still have 6 carbons, but now they're connected much differently, and especially we have a ring that got closed. So I'm going to do a little bit of retrosynthesis. I'm going to start at the end, see if I can't work my way backwards, and particularly I'm going to pay attention to the carbons and the carbon skeleton. Where are they and where did they start? Right? So in looking at the product and I'm thinking about retrosynthesis, I know somehow I had to close that ring. I had to make a new carbon-carbon bond. So probably that's happening somewhere over here. You'll recall the Grignard reagent is the one that makes new carbon-carbon bonds. And what kind of functional groups are present after you do the Grignard reagent reaction? There are a couple different ones, but most commonly what you see is an alcohol. So probably the very last step was taking something like this and converting it into the ketone through oxidation, because this looks a little bit more like the product you get from a Grignard reaction. Then I went backwards and I was like, if this was a Grignard reaction and we closed the ring, then either this bond or this bond must have been the new bond that got formed. So I'm going to work my way backwards, right? What was the step before that? The step before that probably involved something like this, where I made this piece into my Grignard reagent, and then that is the new bond that got formed, and converted that to the alcohol, and so on and so forth. Right? So using a little bit of logic about Grignards, I figure that a couple steps back from the final product, I had something that looks like this. Now I'm going to unfold that, because it's really hard for me to look at that and make much sense of it. So I'm going to unfold that out. What does that look like? That looks like this, okay? So hold that thought for a minute. Let's come back over here. When I'm looking at this one of the things I notice is I have an ester linkage here, and it's not in the final product. In addition, when I counted, I had 5 carbons over here, plus the bonus one over here. In my product, all 6 of those carbons are bonded to each other, which means I need to get this one, right? So I need to somehow take this ester linkage apart so I can grab that bonus carbon here and reuse it. There are a couple different ways to take apart an ester. I'm going to use powerful reduction. You can use some different ones if you want, like ester hydrolysis. Here's my products for ester hydrolysis. I'm sorry, for powerful reduction, right? So here's the organic product with 5 carbons. Here's my bonus carbon over here, right? Let's compare this one, what I got after the first step here, with what I want to make here. If I can make this black one, that will take me to here. So what's the relationship between this one and this one? Let's just look at the carbon skeleton for a minute. In this one, I got 4 carbons all in a row, plus 1 bonus carbon sticking off the 2 position. What do I have up here? Up here I've got 1, 2, 3. I've got 4 carbons in a row. I have have this carbon sticking off the 2 position, and what is this? You know what that is? That's my bonus carbon, and now I know where I have to add it. This bonus carbon has to be added here in the 2 position. It has to be buddies with this one, right? So we have to add a new carbon here, at this point right here. So now I can go back over here and I can say, oh, I have to add a carbon here, which means I must do Grignard. Remember, most Grignards involve a haloalkane and something with a C double bond O. And so there are a couple different options here. This could be my haloalkane. That would be convenient because it's already a haloalkane. I know in this case that this can't be the kind of Grignard where this piece is my C double bond O, because now I have 5 bonds here. That's not good. So I know that this one is probably my haloalkane. And where am I going to get my extra carbon? That's right, from that one right here. If this is the haloalkane, and I'm going to make this into a Grignard, then this has to be something with a C double bond O, right? Like this one. So this, if you want to write out the whole structure, this is methanal, or formaldehyde. Or if you want to just write it like this, yeah, you can. Okay, so we got this piece. When these pieces react together, guess what I make? Now, I've made something that looks a lot like this over here, right? We have and now we're starting to get to see how you might convert this into something that looks like this. We're still not quite there yet. Now we have this unfortunate bit where both of these are alcohols, and they're both primary alcohols, and you might want to react, for example, something with one and not for the other. So before you do this step, one of the things you might think about is, for example, making this into some sort of using a protecting group here, right? So maybe convert this into something else so that you get some differentiation here. But once you've gotten to here, right, you can tweak these, and it's only a couple of steps until you get to something like this. So work on that a little bit more, see if you can't fill in the missing blanks, and let me know.